All right, so our first BloodHound question here deals with checking the number of bars in between signals from a third-party indicator. So Randy has a third-party indicator that generates, entry signals. So we can see, right, it's going long, then it's going short, long, so it's just kind of reverting back and forth. And so his question is he wants to remove any of the entry signals if there are less than 5 bars between the signals. So, for example, let's see, 1, 2, 3. Yeah, so really, all of these signals here that I'm trying to circle with my mouse should be, Randy wants to remove them, right? Because there's less than 5 bars in between. But we can see, right, this first short signal, we got 1, 2, 3, 4, 5, 6 bars until, right, we get to the next long signal here, right? So actually, we don't know if we would see this short signal because we don't know, how far back the previous signal is. But at least we know that this, out of this screenshot, this long signal it will be the only one, left remaining using this. 5-bar separation condition that he's looking for, right? So, I had to make sure that there are at least 5 bars between signals, right? So really what this question is about is taking this third-party indicator signals and filtering them, and only allowing the signals through that have 5 bars in between signals there. I will just start working on the logic tab here on the logic board. Let's see, what should we call this? All right, so yeah, basically we're just looking for a 5-bar minimum spacing, I guess, between signals. I try not to make these names too long because that just takes up a lot of space up, up on the top of your chart there. All right, so there's some kind of a name here for what we're trying to build. Let's see. So first thing I need to do actually is I need to build some signals to work with. So let me, just give me a moment to try and put something together here that I need to work with. Let's see. All right. Yeah, I think this will work here. So yeah, I'm just kind of thinking the one thing I don't know is in Randy's question here, let's see, so he's got a custom indicator. He is, we can see from the screenshot that he is able to get let's see, where's the screenshot, he is able to get that his indicator works with BloodHound, right? So we can see that all these signals, all these racing stripes, right, are from BloodHound here, reading his indicator. But what I don't know is he using one solver or 2 solvers to get these signals here? Let's see. Yeah, well, because he has entries and exits, right? Entries and exits. So I'm going to assume that all the short signals with the arrows are probably the entries, and that the long signals are probably the exits with the blue, blue or green arrows. Let's see, or maybe it's the dots. No, the dot's a different indicator. Yeah, so I'm just going to have to assume that the entries from his indicator is one solver and the exits is going to be a separate solver here. Right, so let me do this. So I'm going to have to make something a little more elaborate here. And again, all I'm doing is I'm just making some entry and exit signals that I can work with to build the logic, right? Because I don't have Randy's, custom indicator there. So I'm just having to make something up to work with, some signals to work with. So basically, I've just kind of made some kind of makeshift, entry signals that I can work with, and some exit signals that I can work with, and of course, what this AND node is supposed to represent is, Randy's, entry signals that he's using from his, custom indicator, right? So I've got some signals to work with now. So we want to know basically when there's a 5-bar, spacing or separation between the entry and exit signals, or even the exit to entry signals. Yeah, so Randy's saying, he's got one solver for entries and one for exits. Okay, great. So, it's kind of interesting how actually getting in, once you start diving into something, all kinds of other questions start popping up that you don't think of before. So Randy, I guess, looking at this now, I think really what you're needing to filter is you want to count the spacings from the exits to the entries, right? I take it that, let's say if this short is an exit signal, if this short is a entry signal, right, that you don't want to block the exit signals if they're less than 5 bars, right? I doubt you. So I just want to confirm with you, Randy, that you're not wanting to filter out the entry signals. This is turning into a tongue twister. You're not wanting to filter out the exit signals. What you're wanting to filter are the entry signals there. Randy, that to me, that's what made logical sense, is that if an entry is too close to an exit, you want to get rid of that entry signal. But regardless, if an exit signal shows up really quickly, that you always want to see that exit signal after an entry signal. So Randy, if you want to confirm with me that really what you're trying to filter out are the entry signals that are too close to a previous exit signal. Right, to me that makes sense. Stripping out your exit signals to me sounds kind of dangerous. Randy, if you want to just kind of confirm that for me. All right, I'm just going to assume that Randy wants to filter out the entries and not the exits there. Okay, so so what we need to do is, right, since we're trying to prevent entries that occur, shortly after an exit signal occurs, then we need to, let's see, I wonder if that, yes, I was thinking about changing the direction I was going to go with the logic, but now I'm still going to stick with the signal counter here. Yeah, so we're not actually counting signals, but we are going to use the signal counter because the signal counter has this look back period. So with the signal counter, we can look back 5 bars and see, was there an exit signal 5 bars ago, right? Right. So really all we need to do is see one exit signal within the last 5 bars, right? But the thing is, we do not. So we're using the signal counter in an opposite way, right? So with the signal counter, if we do count an exit signal, then that's our condition that says, okay, no entries. So we're kind of using a signal counter in an opposite manner, right? So with the signal counter, we don't want an output if there is a signal counted, right? So we're going to turn that off. But we want to know when there are no exit signals, right? So we want to make sure, we want to know when the signal counter has not counted an exit signal, right? So we're going to use the value at 0 count. Right, so this is the output that we actually want to use, is that. Right. So, and since we're only counting one signal, right, all we need is one exit signal within the last 5 bars, right? That's the condition we're looking for. So, so the output style doesn't matter. We can leave it on analog. It's not going to matter. But if you are counting, say, 2 or more signals, if you're actually using the signal counter to actually count signals, and say you want to count 2 signals or you're looking for 3 signals, then most people want to set the output style to digital. But since we're only counting we only need to know if there's at least one exit signal within the last 5 bars, right? And so if there is an exit signal within the last 5 bars, the value of counted would have an output, but we turn that off. We want to know when there is no signals counted, right? When there's a 0 count of the exit signals there. So let's take a look at our exit signals, and let's mark a few here. All right, I will use. All right, so now let me mark some entry signals. Actually, hold on a moment. I need to find a good spot on the chart here to actually work with. All right. So what I did here is a neat little trick here where I can see 2 things, 2 outputs at the same time. So effectively, two signals at the same time here. So the entry signals are going through the OR node, right? And they're generating a full signal here, right? So we can see the racing stripes from the entry signals. But the exit signals, I put them into a extra OR node, and you can see I took the slider and knocked the slider down of that OR node. Actually, oops, I knocked the wrong slider down. I should knock the slider of the OR node down, right? So we can see this is the OR node. So I can knock this slider down, and what we can see is basically this partial output, right? So we can see all these reduced little outputs here, and those are the exit signals, right? So the OR node, it took the exit signals and I reduced the output value, right, down to 0.32, right? So so that means the entry signals, have a full signal output, right, with the racing stripes, and then these little tabs here, right, these partial outputs are the exit signals. And so with this, I can actually mark this. Yeah, here we go. All right, so I want to be counting from the exit signal to the entry. So there's an actual entry signal that'll work out for us. So yeah, there's a little spot that we can work with. All right, so I'm just marking the exit signals now. Okay, that should be good enough. There. All right, so I don't need that anymore. All right, so back to how we're utilizing this signal counter here. So what I was trying to demonstrate is that right from our entry signal, and there we go, right, we want, let's see, at least 5 bars of separation. yeah, there's 5 bars right there. And so with the signal counter, right, if we do not see a signal, and in this case it's going to be, right, an exit signal. So if there's no exit signal within the last 5 bars, then that's what we're looking for, is no exit signals within the last 5 bars. So we're looking for a 0 exit signal count. That's what we want to see there. And so if we look at this, let's see here. Oh, yeah. So now when we look at the signal counter, let's see here. So what the signal counter is seeing, right? Let's plug in the exit signals, right? So all in here, right? The signal counter is seeing short signals, right? Short signals. So if we look at the signal counter's output, and actually, let's see. No, never mind. So yeah, so what we're looking for is the short output here. Right. Now, of course, we can see that there's a long line of long outputs, right? And that's telling us that, oh, it hasn't seen, the reason why we see that is because it hasn't seen a long exit signal in a long time, right? That's the last long exit signal. So if we go down here, right? So once we get to 1, 2, 3, 4, 5, right? Once we get to the 5th one, well, the signal counter goes, oh, yeah, we haven't seen a long exit signal in the last 5 bars. And so it'll start generating an output because there is no long exit signal count, right? And so actually, if we want 5 bars of separation, we need to up the look back period to 6. There we go. Add 1 more. There. Right. So if we count from this exit signal, if we go 1, 2, 3, 4, 5, right? So there's 5 bars after the exit signal, and then we get an output from the signal counter. But what we're wanting to do is we're filtering the entry signals, right? So yeah, so if we look here, let's see if I can move this over. There we go. Right. So there's our short exit signal. And so when we come across, right, so we have 5 bars of no exit signal, and then we get to our 6th bar. And so we have a short output right there. Right? And it's a short output because it was a short exit signal being counted. Right? But we're using it to filter a long entry signal. You know, right? Or basically any kind of entry signal, really. So what we need to do is we need to basically reverse or swap the exit signals here. And so to do that, what I'm actually going to do is, so for example, right, this was a short exit signal, but you know, we don't know if the next entry signal is going to be a long or not, right? It could be a short, right? We could have a long entry and then a short signal for the exit, right, to exit that long entry. But then the next signal, you know, depending on what the market does, the next entry could be a short. So really what I need to do is I need to take these exit signals and make them non-directional. And what non-directional means is, let's see, let's use the addition here. So Yeah, so if I use the addition mode, right, we can see that all the exits, so remember the little triangle here are the exit signals, right? So all the exits, it doesn't matter if it's a long exit or a short exit, right? We're getting a non-directional signal, right? So basically we just want to count, you know, is there an exit? We don't care what direction the exit is there an exit? And then we're going to use that to filter, right, the entries here. So let me change the name here. There. All right. So we want to take, you know, these non-directional entry signals and feed that into the signal counter. And there we go. Let's see. Oh, I thought, let's see. Well, we had an exit to exit. Ah, okay. Oh, here we go. Cool. Well, yeah, we'll have to take a look at those. Take a look at the entries and exits back here a little bit. But, you know, in our little work area here, right? So we now, the signal counter is giving us a signal telling us that it's okay to take the next entry signal, because you know, when it looks back, it hasn't found an exit signal within the last 5 bars, right? So as the signal counter is looking back upon the last 6 bars, there is 0 signal count, right? Which means it's okay to take that entry. And so now the last step here simply is another AND node like that. And so there is our filtered entry signals. And so let's take a look back here. Yeah, there we go. So let's take a look at the entry signals. All right, so as we look at this, so here, that was our last exit signal right there. Right, and so we do have, right, a 5-bar clearance to that next entry signal. And also, yeah, so there was no exit between this entry and this entry. So we even have a 5-bar clearance between that exit and that entry as well. There. Let's see, I thought we had, oh yeah. Yeah, so we do, right, so I'm looking at the signal counter, right, which basically is the signal counter is, simply put, that's our permission or our permissive for the entry signals. And so we do have some permissives, but we don't have any entry signals that lined up there. Let's see. Yeah, let's mark a few more of these entry signals. Yeah, so as we look at our signal counter here, right, basically there were no entry signals when that signal counter said it was okay to allow an entry signal to pass through. So, yeah. So there we have it. So the logic for this is pretty straightforward. Fairly simple. So we take the exit signals and we run them through a long short modifier, and we use the addition mode, right? So the addition mode takes the exit signals and makes them non-directional, right? Both a long and a short. So they're basically just a bar, right? So basically the long short modifier just turns the exit signals into a marker. And then we run it through the signal counter, and we want to know when there is no count, when there's a 0 exit signal count. Right? That's the key there. And then as far as the spacing between bars, all you need to do is either increase or decrease the lookback period, and that's how you can increase or decrease the separation between the exits and your entry signals. All right. So the signal counter, it's outputting when an entry signal is allowed, or I should say where an entry signal is allowed, and then you just combine it with an AND node, right, to your entry, right there, just like that. So now just a little tip on logic, on Boolean logic here, just a little tip. When you have an AND node going into another AND node, that's really not necessary. Whenever one AND node is going into another AND node, you can consolidate them all into one AND node. So it's the same logic there. So we could actually just get rid of that AND node and connect that in, and bingo, there we go. And so now we have our filtered entry signals. Right? We could just do that just to save us, some extra nodes there. But sometimes it just looks prettier if we just use an extra AND node. Right? Sometimes it just looks a little better, like that. All right.